Now we'll discuss the distributive property. The distributive property of Boolean algebra. Okay. So this is our building. This is our office building B. Okay. So this is our home A. So we are going from A to B, but now what happens? The road is like this. From this point to this point, there is one road, and there are two options from this point to this point. We'll call this X, call this Y, this we'll call this Z. So this means X is compulsory and Y and Z are optional. X and Y are Z. This means this, right? However, we can say this like the path from X to the path consisting from A to B, one of the paths is X and Y, right? When we consider the paths going from A to B, one of the paths are X and Y, another of the paths are X and Z, and these two are optional. You can either go through the path X and Y, or you can go through the path X and Z. It does not matter, right? So this is the distributive property. X and Y or Z is equal to X and Y or X and Z. There is another similar one, that is X or Y and Z. So there is a path X to go from A to B, and there is another path from this point to this point called X, from this point to this point called Y, and from this point to this point called Z. Okay. So now you can also say that there are options here, right? That you can go X or Y, but also X and Z. Means both are compulsory. This is a bit counterintuitive to understand. There can be another way to understand this. So you know that X and Y and Z, these are the variables whose state is either blocked or free. So X can be blocked, X can be free, Y can be blocked, Y can be free, Z can be blocked, Z can be free, right? So in the first time you have the option that if X is blocked, right? So you are saying that you have to follow this path X or Y and Z. Then you want to put it in the form that we'll take two compulsory paths, right? So two compulsory paths. Suppose that X is blocked and Y is free. Then this is among the compulsory paths, and then X is blocked and Z is blocked. This is also compulsory path. So suppose X was free, then what will happen? Then, and if you wrote it like X or Y and Z, okay, then what is happening? Then in the first part of the problem, X and Y both are free, and the second part of the problem, Z is blocked. So can you go? There is a path from A to B. No, but we can clearly see that there is a path from A to B. If you are following this one, then what happened? In the first path, X and Y both are free, so you are free, and in the second part Z is blocked, So you are concluding that the road is blocked and there is no way to go from A to B. But clearly that is wrong. There is a path of going from A to B. But if you consider this for this equation, then you'll see that X or Y, we are considering the first part, both are free. Yes, then this part is free. And then we are considering both X and Z, both are optional. So one of them is free. Yes, X is free. So yes, this part is also free, this part is also free, and the outcome is that the road is free. You can go from A to B. So prove that this is wrong and this is right. Okay.